Okay, so we are finally on, which is actually chapter 2, but the third unit, derivatives. So the whole last unit was kind of the old school way to do derivatives, and we're going to actually work mostly with that again today, which is nice because it'll still help you with your test on Friday, as well as what we do next day will actually even help you even more. So sometimes when you start a new unit, it's totally different, like you're doing perms and columns and you turn over to, doing trig or something doesn't really help you, but this one will help you a lot with the next, or with the last test. Okay, so what's a derivative? Okay, so your derivative, simply enough, is basically slope. Okay, it'll help find slope anywhere. Now, we've always been finding slope since like grade 6 or something, right? But those were all straight lines. Now you can find slopes of curves anywhere. And that'll help you to actually draw a curve, because you, as you know, you don't get to use a graphing calculator for your exams. So it's going to help us in a couple units to be able to find exactly what a graph looks like. Now, it also helps us a lot with physics, helps us a lot with max-min problems, helps us a lot with rate problems, and we're going to do that next unit when we do applications. Now, when you see y equals f of x, that's your original function, the derivative will look, there's many different notations, okay? There's y prime, okay? That would be the derivative of that. You can also do dy of dx, okay? That is the derivative done to x. Okay, there's also capital D with a little x subscript of y, that's the derivative. You can also do f prime of x and d dx of the equation f of x. So these are all the notations that are used, and depending on which textbook you pick up, one will be used more than the others. This one is probably, this is the most modern, and this would be the most, I would say, used in university. So we're going to stick to these two, and maybe this one a little bit, but these two are very similar because y is f of x. And the rest, like this one here, I don't think I've ever used in my life, but it exists. So we will put it down. Now, a derivative defined. Now there's two kind of interpretations of a derivative. Now the first one, and we've done lots of these already, and that is your tangent slope. Okay, so maybe you had like a function that looks like this, right? Something like that, right? That would be the slope at that point. Now, what it becomes more useful is finding instantaneous rates of change. So a derivative shows how quickly y changes for a given change in x. And that's why it's dy over dx, right? Like, show me all the changes in y to x. So the higher the derivative, meaning the greater the magnitude, the faster y is changing relative to x. This isn't a new concept for you guys, okay? If the run changes, or the rise changes more than the run does, it's going to be steeper. So if a positive slope means y is increasing, a negative slope means that y is decreasing. Now, probably the most common thing people would say is just look at the graph. You can see if it's going up or down. We won't have that convenience anymore. We're going to get an equation, and they're going to want to know, when is this increasing? When is this decreasing? Before, we put it in a graphing calculator. Oh yeah, okay. I can see what it's like. I mean, I could give you the most basic example. Let's just throw in y equals x squared. Where is it increasing? Well, the slope would be increasing here, and here, and here. Okay, yeah, that's when it's increasing. When is it decreasing? Well, it's decreasing there, there, there. Okay? Now, what is going to be nice is I'll take that equation of that graph, y equals x squared. I'll do the derivative on it, and I'll plug in points. And wherever I get negative values, that's where the slope's decreasing. Wherever there's positive values, that's where the slope is increasing. Wherever I get a value of 0, that is where we have a horizontal tangent. And that'll give me maximums or minimums. Okay? So, derivatives of functions. Now we're called to find the tangent of y equals f of x at the slope, at the point x equals a. We can use two equations. So these should be, review to you, the first one we did that I said was kind of the more student-friendly one, when x goes to a, and we'd go f of x minus f of a over x minus a. Oh, f of x minus f of a over x minus a. And then the second one was f prime of a, or the derivative a of f is limit as h goes to 0 of f of a plus h minus f of a all over h. Okay, these two will be the ones tested on Friday. Now, in this unit, now this was really good. These were really good at finding the slope for that point. But to find the slopes anywhere on a graph is what's ideal. We don't want to put in a ton of work every single time to be able to find the slope anywhere. So we're going to kind of change it a bit because we want to find the slope for all points of x. So how do we do this? Well, it's actually not a huge change, but we're going to change basically a to x. That's all we're going to do. So how do you find MPQ of this graph here? Because remember, here is kind of where I'd like the slope right now. I want the slope of that point, right? But we need 2 points to do that. So, well, we could find the slope using that. What is really nice, though, is if we could get the point really close here. And that's still x plus h. But as you see, h is a lot less. It's a lot smaller there. The ideal would be to get, because that would give me this slope, we want to get it even closer. So we want to make h approach 0, right? So we're going to do f of x plus h minus f of x all over h. So all we're going to be doing now, instead of actually finding it for one point, once we find the slope of this curve, we can start putting in different x values, and we'll be able to find any point, or any slope, any point on that curve. So, and today's kind of the last day we're going to do it. using limits, but here is going to be the limit formula. And if you look above, all the way up here, what's the only difference between number 2 and this is we're just changing, instead of putting a in there, we're just going to put x in there. Okay, so this formula will calculate the slope of a tangent for any value of x. Not just the one that we were given. If you look at all the last unit, they're like, find the slope here. Okay? And remember, I was actually figuring out what f of a was, and we're all like, yeah, they give us the point. Okay? Because I'm in such a habit of actually using just the formula to find my slope, they're not going to give us the nice xy point anymore. So here is a nice example just to start some off. Now, we've got f of x or y equals 3x squared. It says find the slope at 1, 2, 5, and I also want to change this to -1, -2, and -5. Now, sometimes it's nice when you're starting these off, right, just to kind of have a visual of what this is. Okay, so it's a bit steeper than y equals x squared, but this is what y equals 3x squared looks like. Now, by looking at that, you should be able to tell me where you think the tangents would be increasing slopes and where they would be decreasing. Okay? Because this is one of the rare times you'll actually have the graph to look at first to say, this is what my answer should look like. But we're going to have to get to the point where we don't have the graph to look at, so we have to trust our answers. So the way that we can find the slope is by using the slope formula. So f prime of x equals, now we're going to put x plus h squared minus 3x squared, oops, yep, I guess I don't need a bracket there, all over h. Okay, so you take your formula and you put x plus h into it, or I shouldn't say formula, your equation. You put x plus h in it, and then minus x. And we're not going to be solving for a specific point anymore. Because if I was to do this using my last unit, I would have to do this for all 6 of those points. I would have to do 6 limits. Okay, so today we're going to learn how to do it once, and then just plug in x values in, and you'll find your slopes at those points. Okay, so this is always the fun part, and by fun I mean not fun at all. We've got to expand that x plus h squared, and this is a nice little formula. Sometimes they get pretty brutal. So we've got to remember to always FOIL this. Don't go x squared plus h squared. You guys need to know that by now. So we're going to take our 3. We'll just keep that out front. Oh, yeah, I guess I have to start teaching some good habits. We always want to put limit as, ooh, I even forgot to do that already. Okay, we forgot to put the limit in there. Equals limit as h goes to 0. So limit as h goes to 0. Remember, we want to get that difference, that h, as small as possible. So we want to approach 0. So that would be 3. And then if we're going to FOIL this, it'd be x squared plus 2xh plus h squared. And then this one is just going to be minus 3x squared. And this is all over h. So the limit as h approaches 0 is 3x squared plus 6xh plus 3h squared minus 3x squared. all over h. Okay, we can cancel these two. And then we're left with the limit as h approaches 0 of 6xh plus 3h squared all over h. So these become quite routine after a while, that you'll see, okay, those cancel, and then we can always, in the next step, factor out an h, leaving me with 6x plus 3h. That's all over h. Okay, and then you'll always be able to cancel that h, because you can't put in 0 until we get rid of it on the bottom. So the limit, as h approaches 0, of 6x plus 3h would equal 6x. So f prime of x equals 6x. That's the derivative of the function 3x squared. Now, that's not the slope yet, okay? We find the slope now by putting in x values. So, f prime of negative 1 would equal 6 times negative 1 equals negative 6. F prime of negative 2 equals 6 times negative 2 equals negative 12. F prime of negative 3, or negative, what did I say, 5, would be 6 times negative 5, which equals negative 30. We're actually not going to do any of the example 2 questions, so we can keep working down here. F prime of 1 equals 6. F prime of 2 would equal 12. Oops, I guess I'll write that in there. 6 times 2 is 12. And f prime of 3 equal 5 equals 6 times 5 equals 30. So let's just draw this again. If this is my graph, what this is saying is the slope formula for this graph is 6x. At 1, so say at 1, this would be my slope. It would be 6. Do you see at 2, say 2 is about here, the slope is increasing. And at 5, okay, which is way up here somewhere, it is very steep. And it's at 30. But do you see that they're all positive slopes? Okay, that means if they're positive, they're increasing. At negative 1, we would have this slope, right? At negative 2, we would also have a negative slope. And then at negative 5, again, a very steep slope. Now, this also shows another obviously huge piece of information. If you're changing from negative slopes to positive slopes, what happened? That there must have been a 0 in between. And a 0 always means a max or a min. Okay? And not next unit, but the unit after, we're just going to be graphing, and you're just going to be using derivatives and second derivatives to be able to learn how to graph, okay? But whenever your slopes go from negative to positive, it must always be a min, and if they went from positive to negative, they must be a max. Okay, we're just going to do one more. This one is a bit more on the brutal side, and this one just kind of has another little piece added to it. It says state both domains. Okay, so in the original, what would be the domain? So the domain is x cannot equal negative 4. Okay, now it wants the domain of the derivative. Okay, so let's do it. So f prime of x equals the limit as h approaches 0 of, now we're going to put x plus h into the, so that's 3 minus 2 times x plus h all over 4 plus x plus h minus 3 minus 2x over 4 plus x, and that's all over h. So you can see why these turn into, and if you turn back to the page before, it had all those examples, and they're pretty obscure and very, very mean examples. This one isn't that nice either, but you'll have to know how to do them to this level. But I would, on the page previous, I would never test you on something like that. So I thought, what's the point? Because sometimes it just turns into a series of how far can I go without making a mistake. And these are hard to do without making a mistake. One little negative sign, you're not going to get the same derivative as the person that did it. Now, what really makes these easier is if you actually take out 1 over h, and then you can just deal with just the top right now, okay, which is the numerator. And even though that 1 minus h is on the third level, we're still talking about all of this over h. So we're just going to do all of this, and this means it's over h when you pull that out, okay? But it's just nice not to have it hanging around right now because we've got some work to do. Now, in order to get these together, we're going to have to do it over a common denominator. And my common denominator, I am just going to have those multiplied together. Okay, it does make it easier. So this would be 3 minus 2x, oops, 2 bracket. Oh yeah, I'm going to just, yeah, 2x minus 2h times 4 plus x minus 3 minus 2x times 4 plus x plus h all over 4 plus x plus h times 4 plus x. Now, a little kind of hint here, just put a little, is just leave denominator in factored form. Don't go and multiply the denominator altogether because you're going to end up having to factor it out later to try and cancel things. The numerator is going to be enough work for you, so you're just going to concentrate on that. Okay, so we got lots of multiplication, right? Because this 3 has to go to both of these, and the negative 2 has to go to both these, and this negative 2h has to go to both these. And then I've got to worry about the other 2. So lots of chances to make mistakes. I have it all worked out in front of me, and I will probably make a mistake. So limit h goes to 0, 1 over h. So we should have 12 plus 3x minus 8x minus 2x squared. Okay, and then I'm on the minus 2. Now I got minus 8h minus 2xh. There's half it done. Okay, now this minus sign here, this belongs to, so it's going to be negative 3 times all of these, and it's going to be positive 2x times all of these, okay? So you got to keep that straight. So negative 3 times all of that, that'll be minus 12 minus 3x minus 3h, and I'm going to run out of room. Okay, and then I got to go plus 8x plus 2x squared plus 2xh. And that is all over 4 plus x plus h times 4 plus x. Yeah, I brought my next, so that's positive 2, and then I just multiply that to everybody. Okay, so you're going to look for things up top. Do you see up top there's a positive 12 here with this negative 12? Okay, there's the positive 3x with the negative 3x. There's a negative 8x and a positive 8x. There is a negative 2x squared and a positive 2x squared. Okay, I got negative 8h and a negative 3h. Right, yes, good. My negative 2. Okay. Okay, so is that negative 3h or negative 2h? But I got a different total when I did mine. Because that's going to give us, oh no, that's good. Ooh. Okay, so limit as h goes to 0 equals 1 over h times negative 11h over 4 plus x plus h times 4 plus x. Okay, now you can see these h's cancel here. Now, the next thing since we can now put in h, that would be negative 11 over 4 plus x plus 0 times 4 plus x. So this equals negative 11 over, there's basically two 4 plus x's multiplied to each other. So f prime of x equals negative 11 over 4 plus x squared. So if they gave me x values, I could find the slope at different points in the graph. So what's the domain? Domain is x cannot equal -4. So, is that, yeah? What's wrong? What's good? Okay. So kind of a wrong conclusion can be drawn about this, so that's why I want to talk about it, is that domains are not always equal, okay, but often are. But one thing I can say for sure is that f prime of x is domain is at least a subset of f of x. Subset means that it'll be at least part of it. Or if x is, let's say x had to be between 3 and 8, then it can be 3 or 8, 4 or 7. It has to be within 3 or 8. It won't get bigger, okay? Your domain will not increase. So if x wasn't ever allowed to be 4, it makes sense that there shouldn't be a slope at that point, or -4. Okay? That doesn't make sense that, well, the point doesn't exist, but now it does, because I found that when I did a derivative, that I could find the slope at that point. So you still always have to be aware of the original domain. Okay, so here, and then I just want to add a bunch more. Just kidding. Just one. Little 8D. 8D is kind of your secret of success for this whole unit. You do that one.